Hello everyone, and welcome to the inheritance programming example. In my previous video, one of the things I stated to you, and I think it's absolutely true, if I go out and I look on the internet trying to find good examples of inheritance is not easy. They're either way too simple, like some of the things we reviewed in the previous video, or they're way too complex that you can't even follow them. I wanted to come up with, and I did find some stuff on the internet that kind of help me with this, a program, if you will, that makes it a little bit more simple, that kind of gets a few things across. And it also introduces a few new things that's really focused on Python, nothing else but Python, as we kind of go through it. This particular application basically has a class for a clock where it can actually go to the next second and go to the next second and go to the next second. And then it also has a class for a calendar. And what we're going to do is we're going to imagine that we need a class that's going to incorporate both of them. And so we're inheriting both the clock and the calendar in this case here, okay? Let's go ahead and follow this a little bit. There might be a few new things in here that you've never seen before, but I'm sure you can figure out. Some things I will describe as we kind of get into it and kind of go from there. But I think this is a good basis for you to try to understand inheritance and see if you can apply it to your assignment for this week. All right, so this clock class is now, as you understand, we have our init, okay, our underscore init. This is actually called dunder. And one of the things you'll, I don't know, it's two underscores is called dunder, double underscore for short. So if you want to be really cute in Python, you call these the dunder methods. And I'm going to show you another one here in a second. And I actually put out on your resources for this week some materials that I want you to review and listen to. There's actually a video that will go through some of these other dunder methods and how you can use them. We're going to use another one in this particular instance here in a second. So we bring in hours, minutes, and seconds. As you see, we actually set these to zeros, so whatever comes in, if it doesn't come in, these will be zeros. Remember that? So if we actually don't pass hours, minutes, and seconds, then it will become a zero based upon what we do, correct? So if we just pass in hours and minutes, which is fine, the other one would be seconds. Remember, if you recall that, okay? In this case here, so we're bringing those in. We have a method here called tick. That is going to take the seconds and it's going to ask some questions. You can kind of look at this logic. I'm not going to go through it. For the most part, what it's basically doing is ticking and implement and going 1 second at a time. It'll change the minute once it hits 59 and goes to the next one, sets the minutes to the next one, and so on and so on. It'll also deal with the hours and everything as it kind of goes from there. As you see here, it has another method called display that is going to take and print these three particular, let's say, placeholders. These are actually called placeholders. I gave you, again, some resources to go look at these things, okay? This might be a little bit different, especially for those who have not taken any other advanced classes other than Programming 1. What this is basically doing is having a placeholder here with the colon, placeholder, the colon, placeholder, colon. These are all digital placeholders, or I should say decimals in a sense, that is going to replace those with hours, minutes, and seconds. Does that make sense? All right. If I called this, that's basically what would happen. It would take these hours, minutes, and seconds and actually just display them accordingly. Another way of doing this is called what's another dunder method. Another magic method is what it's actually called in Python land. It's called underscore dunder, if you will, str. And it's going to do the exact same thing, but it's going to be really slick when we actually call this, and you can see how it works. So kind of pay attention to it. Once again, I provided you with resources and another video to review how these actually work. I highly recommend you look at those, and I want you to try this out in your own assignment for this week, okay? Just to kind of see how these little magic methods that are part of a class works for Python. But I want you to note that these dunder methods are not available in any other language, at least I know of. There might be other such things out there, but these are very unique just to Python, okay? Pretty powerful little things. Again, they're kind of intrinsic type of things for classes that you can actually use. There's several of them. You'll go out, my resources provide you with those lists, and you might come across opportunities to use them. I would believe this Dunder STR is something that you could use quite a bit to help you display your output. Okay? And so in this case here, we have those two pieces. And then we have the calendar. In this case, we're creating a calendar, and we are doing 31, 28, 31 all the way through. Now, the one thing we haven't really talked about in this course so far is data structures. There's a purpose and why I have not talked about those. It's particularly because of where this course lies in the current curriculum and making sure people are well aware of data structures when it comes to programming too, specifically arrays. When it comes to Python, there's different types of display instructors. One's called a list, one's called a tuple, and one's called an array. We will review those. I plan on doing those before the end of the course to make sure that you understand these and how they're applied within Python so you can actually utilize them and so on. But at this point in time, it's my belief that you should be pretty much aware of what an array is. In this case here, this isn't an array, but we don't call an array in Python, even though you can. But it's a little bit, arrays are dealt with a little bit differently, and they're a little bit more powerful. These are actually called a list or a tuple. In this case, it's a tuple, meaning there's round brackets around it. Those round brackets make it a tuple. And what a tuple is a list that you cannot change. Okay, lists you can change in Python, but tuples you cannot. So if I tried to change this, it would give me an error if I try to do so. So basically what this is the days of the month, the amount of days in each month all the way through. Why would you want to change that, correct? I guess for leap years, I guess. And so with that case, that's what this is doing. So it's going to go in, it's going to determine if it's a leap year accordingly, and then it's going to advance itself throughout this. And you can actually see that's actually then looping through the months here. In this case, months, so basically what the month was, whatever we brought it in, it's going to look at the this tuple, if you will. This is the index. Everybody should know about indexes by now from programming 2, pointing to this month's tuple, if you will. Okay, and it'll be 228 as I add 1 to it. So for the most part, what this is doing is advancing also as it kind of goes through. Okay, another one of these dunder. All these terms, all these little dunder STRs, that's going to print everything out accordingly with slashes and so on in between there. The plus signs for concatenation in regards to that. The str is a formatting string. I provided you once again with resources that actually show another method. That's not really a method. This is actually a function that will basically print this out for you. All right, don't get too concerned about this. It's a little bit over your head. Go look at those resources. We'll play around with those a little bit more as we continue on, but they're not really too hard. Go look them up and Google them a little bit, and I think you'll be really easy. If my resources I provided to you doesn't explain this well, but they're pretty self-explanatory. They're kind of like the toString in VB, okay, or the format currency, if you will, or format whatever. That's what they're doing. It's just basically a way of formatting in a string, if you will, in VB. I'm sorry, in Python. toString is really the one if you're used to that by now. Okay. In this case here, we got our class. There's our child class. These two are actually our super classes. We have clock and we have calendar that are our super classes. Our child class then is going to inherit both the clock and the calendar. Do you see that? Pretty easy. It's going to have its own init where it's going to combine these two. Look how this is doing it. Because it needs to combine them, it needs to have its own init where it's going to bring in all 6 of those particular variables. Okay? In this case here then, I'm going to use the calendar, I'm going to init, and the clock init to do all its work, which is basically just put them into, I believe that's pretty much all they do. They just put them into their instance variables right there. Make sense so far? In this case here, there's another little dunder thing here, str, that actually combines the calendar and the clock. All right, so let's kind of play around with this real fast, and I'm going to go ahead and comment out some stuff here. And let me go back up and fix this number 3. There you go. And then the first thing we're going to do is we're going to create a object here called calendar clock, right? It's called X basically, I'm sorry, but we're going to instantiate calendar clock and we're going to pass it 24, 12, 57. That's going to be these three right here. Hours is going to be 0, minutes will be 0, and seconds will be 0, okay, in this case here. And all we're going to do is then print off basically this right here, what the calendar is and what the clock states. And this because we're passing this in, for the most part, we're not doing anything else with it other than passing it in and seeing what the results are. So the result should be, if we do this correctly, let's see, day is, so it'll be 24/12/57, and then we should have 0:0:0, right? Because these are all zeros right here. We haven't done anything. We haven't passed any data to them. Let's go ahead and play around with that real fast. And as you can see, yay, I was right. 24/12/57, 0:00. That is not my birthday, so don't worry about that. I am not that old yet. And so there you go. So that was pretty boring, right? So basically what this did was, all it really did was initialize and put those things into its variables. And then we basically returned these dunder methods, if you will, of each one of these. We called them where it formatted the hours, minutes, which was basically zeros with colons between them, and this one with the slashes. Pretty simple, eh? Huh? Pretty nice. Okay, pretty easy. The rest of this code then does a little bit of something here, and again, it's not overly important what it's doing or really understanding the logic. It's going to go ahead and it's going to advance at 1,000 ticks, with basically 1,000 seconds. So after we advance at 1,000 seconds and actually advance our years by 1,000 days, in this case, as we draw an X tick. So X tick in this case, calendar clock tick, is going to inherit this tick method right here, where it's basically going to, time will advance by 1 second, and then it will also do the advance where it's going to advance everything by 1 day. And then and in the end, our dates should change accordingly by 1,000 days and by 1,000 minutes, okay? So let's go ahead and run this. Does that make sense? So the calendar clock is our object. That's our child. That's what we instantiated. It became X. That's our object. But I can call the tick and the advance because we inherited those through the clock and the calendar. Make a little sense? So we separated these things. Why were they separated? Once again, back to analysis, back to design. Somebody decided at some point in time that we needed to have an object that's for clock and we needed to have just an object just for calendar. And we're combining the two here. That's the point. Separation, one purpose, and then reuse of everything. So let's go ahead and run this. And then as you can see here, 24/12/57, okay, after 1,000 days, which looks like, see, 1,000 days, what's that? Roughly 2 years or so. Looks like about right. So now we're at 1909. So about 2.5 years, we're now up to 1960. And 1,000 seconds, I said minutes before, but it'd be 1,000 seconds is 16 minutes and 40 seconds. Is that correct? So 16 times 60 plus another 40. I guess I'm saying that right. So 16 times 60, quick, somebody do that. Look that up. I'm sure it's 960 seconds. I'm not going to do it right now, but you can look it up. And so with 40 seconds, that should be 1,000 seconds. So it actually implemented, everything worked. The goal, once again, wasn't so much the overall logic. It's watching how this inheritance worked with these two particular base classes, super classes, parent classes, whatever you want to call them, and then incorporating those into our child class through a multi-inheritance type thing, which other languages don't do very well, but Python seems to do it very, very well. As you can see, especially being able to do this right here, that's where the power comes from. But nonetheless, we can do that. Now, once again, we could have done this as a cascading type thing where the calendar, inherited the clock, and then the calendar clock inherited the calendar, and go from there. We can do that too, but basically you see how this works, and it's pretty clean. But that's what inheritance is all about. Hopefully that makes sense to you, that we're inheriting things that are derived one time and one time only, and thus maximum reuse. All right? So on top of that, you learned a little bit about some dunder methods please go look those up a little bit and go look at the resources I provided you out on Blackboard to review those a little bit more. And again, there's a nice little video out there that kind of explains it really nice. And there you go. Okay. Good luck to you. Try your hand at this through your assignment. Once again, we're testing a theory. We're trying to understand the theory and put it to use right now. The practicality is not quite there. That's what's hard about teaching this in a classroom. You just need to understand what inheritance is and what it's actually doing. Then later on, based upon the analysis, you know what it's all about. All right? Good luck.